Hello all, this is Nandini, Assistant Professor, Department of Full Stack Web Development. So in this session we are going to discuss about tracking methods in AR. So we discuss. In AR, we discussed different type of tracking methods in the last session. So here we can define and we can also learn what are the position and orientation of the virtual objects, what are the common tracking methods, and how these type of tracking methods for interacting the AR experience. So these are the content we are going to discuss. So there are the common tracking methods are marker based, markerless, depth sensing, initial sensors, and sensor fusion, cloud based tracking. So these are the common tracking methods used in AR. So let's discuss one by one. The first one is marker based tracking method. So this type of methods are used in physical markers like any checkerboard patterns or any kind of QR codes or black and white symbols. So these are defined as a marker in AR. So in marker based, first we have to detect the images. So if we want to detect the image, we have to use any kind of hardware devices. So here we are using cameras and sensors to detect and track the markers to determine the position and orientation of the virtual objects. So in this marker based tracking, it is provide a precise and robust tracking, so which requires every markers in the environment, and this type of markers produce a accurate result for users. And the next one is markerless tracking. So in this markerless tracking, the important topic is feature based tracking. So instead of markers, we can use the feature based tracking, and in this feature based tracking, it provided different type of features in the real world. And it is also calculating the edges, corners, and texture points. So in every computer, algorithms identify and track these features. So and to calculate the estimate pose of the virtual objects. So it doesn't require markers. It depends upon the presence of sufficient unique features. So these are the importance of a markerless tracking. And next one is SLAM. So the SLAM is nothing but simultaneous localization and mapping. So it combines the real-time mapping and environment, which is tracking the device pose. So it is used in AR to build the map in the real world surroundings, and it is also tracking the device positions. It is commonly used in mobile app, and it is also used in AR headsets. And next one is depth sensing. So in this depth sensing, it is classified into three types. There are structured light, TOF, and LIDAR. So the structured light, it is nothing but it is capturing the depth images, and it is also determine how to measure the surface and the environment. So this data is used to generate the depth map, and which helps to track and calculation the handling the AR environment. And the second one is time of flight. So it helps to measure the time taken by light to bounce off the object in the environment. So this information is used to calculate the depth and improve tracking accuracy. And the third one is LIDAR sensor. So it is an important sensor in AR. So it helps to measure the reflection, and it is also provide the highly accurate and depth data for making them for the suitable tracking, and it is also tracking the environment mapping. And next one is initial sensors. So these sensors are used in mobile devices and AR headsets. So it helps to measure the acceleration and angular velocity. So these sensors helps track the device orientations and movements over time. And the next one is visual odometry method. So this method which helps to find out the movement of the virtual objects and frame the every camera sets. So and it is also calculate the motion and the position of the particular an object, and it is used in SLAM methods. And next one is sensor fusion. So it is nothing but combining the multiple tracking method and sensors like a visual tracking. So this type of tracking which helps to improve the tracking accuracy and robustness. And the next method is cloud-based tracking. In this cloud-based tracking, it is a heavy processing, and it is also tracking the calculation which is offloaded to the cloud service. So this approaches can enable the AR experience on less powerful devices. So in every tracking method has its advantages and it is also the limitations. But in many cases, the combination of these methods is employed to provide the best tracking performance across the various environment devices. So this choice of tracking method, it is depends on the factors like the desired level of accuracy and the complexity of an AR experience. So these are the tracking methods used in AR. So this is the assessment. These are the reference. Thank you.